Let's try another question, which is also taken from SPM 2022. Diagram 5 shows a straight line AB intersect the curve y squared equal to x plus 9 at point A. Okay, fine. For the first part, we want to find the gradient of the tangent to the curve at point A. So this is a tangent of the curve at point A. So this is point A. So before you get the answer, you know your answer must be positive, right? Because this is going upward like this. So it's a positive gradient. Okay, we want to find the gradient of a tangent. We need a gradient function. So what is gradient function? dy by dx, right? Y square is equal to x plus 9. This is y squared. So I want y. So I'm going to square root both sides. Y is equal to square root of x plus 9. It's actually we have two parts, plus and minus, because another part is over here. But now we only interested on the upper part. Therefore, I only take the positive part. Okay. So y is equal to square root of x plus 9. Square root of x plus 9, I can change it become, I can write in this way, right? X plus 9 raised to the power of 1 over 2. Now I can start to find the first derivative of this, dy by dx. dy by dx is equal to, okay, bring down to 1 over 2, copy this whole thing, and then don't forget the power we have to minus 1. 1 over 2 minus 1, you will get negative 1 over 2. And then you need to differentiate the term inside the parentheses. So for this one, if you differentiate this one, you will get 1. So differentiate this one, you get 0. Okay, so dy by dx is equal to 1 over 2 times x plus 9 to the power of negative 1 over 2. Okay, instead of writing this way, I can write this way as well. This is dy by dx. Okay, so negative, right? So I'm going to move it, go downward here, become the denominator of the fractions. And you have power 1 over 2, which is square root. Okay, so these two are the same thing. Now, we want to find the gradient of the tangent to the curve at point A, means that when x is equal to negative 5. So I'm going to use this gradient function to help me to get the gradient of the tangent. Let me write over here. When x is equal to negative 5. So dy by dx. Or maybe I can write this way. Gradient of tangent is equal to dy by dx, which is equal to 1 over 2 times square root of x is equal to negative 5 plus 9. Okay. Negative 5 plus 9 is equal to 4. Square root of 4 is equal to 2. So this will give us 2. 2 times 2, you will get 4. Okay, so this is the answer for part A. Now let's try part B. We want to find the area of the shaded region. So the area of the shaded region is over here. So I'm going to break this shaded region into two parts. So first, I'm going to use integration method to help me to get the gradient here. And then for the second part, I'm going to use trapezium to help us to get the area here. Okay, so let's look at this trapezium first. I need the length here and here, right? The length here will be 3 over 2, which is 1.5. So what's the length here? This is the height of the trapezium. So still remember, how do we find the area of the trapezium? Okay, let's say this is 90 degrees, and these two sides are parallel to each other. This is A, this is B, this is height. So the area of the trapezium is 1 over 2, and then times the sum of the two parallel sides, which is A plus B times the height. Okay, now I'm going to use this formula to help me to get the area here. So here is equal to 5 units, right? Because this is negative 5, it means this is negative 5. Okay, so this means that here 5 units. So how do I get the height here, the length here? So I need the h. I need the value of the h. Okay, given by the question, the curve is y squared is equal to x plus 9. So I want to find the value of y when x is equal to negative 5. When x is equal to negative 5. So y squared is equal to negative 5 plus 9. So y squared is equal to, this is 4. So y is equal to plus minus 2. So since this is positive part, right? So we know the h is actually equal to 2. Okay, now this is 2. This is 1.5. Now we have all the information that we need to find the area of the trapezium, right? And second, when we want to find the area of this shaded region, we need the coordinate here, the x coordinate here. So how to get the x coordinate here? So same thing, y squared is equal to x plus 9. We are going to use this function to help us to get the x coordinate. On x-axis, y is equal to 0. So I'm going to replace the y by 0. Okay, so x is equal to negative 9. So this is negative 9. Now I have all the important information that I need to find the area of the shaded region. So I can start finding the area of the shaded region now. Okay, let me do integration for this part first. So I'm going to use a formula because I look downward like this, right? To the x-axis. So I'm going to use a formula y dx. I'm going to use this formula y dx to help me to get the area here. Okay, so this is negative 9 and negative 5 y dx. Okay, y squared is equal to x plus 9. So y is equal to this, right? Y dx. If this is dx with respect to x, the lower limit and upper limit will be taken from the x-axis. Okay, now we can start to do the integration. X plus 9 power at 1. So it becomes 1 plus 1 over 2 will become 3 over 2. Whatever you write here, write the same thing for the denominator. And then you need to differentiate the term inside the parentheses, which we will get 1. Okay, upper limit, lower limit. Okay, so I'm going to change the way of writing this. Over 3 over 2, it means that times 2 over 3, right? 2 over 3. Okay, so now I'm going to substitute the upper limit and lower limit to help me to get the area here. Okay, let me write over here. 2 over 3. So copy everything, just change the x, become negative 5. Minus, same thing, copy everything, but this time we will change the x, become negative 9. Okay, just press your calculator. So this is 2 over 3 times, so negative 5 plus 9 is equal to 4, right? So times 4 to the power of 3 over 2. Okay, this is equal to 16 over 3. So here, negative 9 plus 9 is equal to 0. 0 raised to the power of 3 over 2, you will get 0 as well. So 0 times 2 over 3, you will get 0. Okay, so this is the area of this part. 16 over 3. Now, let me find the area for the second part. Now, this one you don't have to use the integration method. You just use normal trapezium area formula to help us get the area of this trapezium. Okay, area of the shaded region. This part, 16 over 3 plus the trapezium. Okay, trapezium start with 1 over 2 when you want to find the area, and then find the sum of the two parallel sides. So this is 2, this is 1.5, 2 plus 1.5 times the height of the trapezium. This will be 5. Okay, just press your calculator. This is 35 over 4. Okay, so 16 over 3 plus 35 over 4. Okay, you will get 14 and 1 over 12 square unit. So if you want to change it to fraction, if you want to change to decimal, it is equal to 14.08. We just round off it to 2 decimal places. Okay, this is the answer for part B. Now let's try part C. For part C, we need to find the volume generated in terms of pi when the region bounded by the curve over here, the straight line y equal to h, it means this straight line. Okay, so this is y equal to 2. And the y-axis and also the x-axis. This is y-axis, this is x-axis. It means that, in other words, we want to find here. Okay, the volume generated when this region is revolved through 360 degrees about the y-axis. So be careful, y-axis or x-axis. This is y-axis. So for y-axis, later on we are going to use a formula. Since this is y-axis, right, dy. So we will be using this formula, pi x squared dy. So from here, you know that you need x squared, right? Okay. So pi x squared, y squared is equal to x plus 9. Let me find x squared first. So y squared minus 9 is equal to x. So from here I know that x squared is equal to y squared minus 9 squared, right? Okay, so let me do some expansion for this one. So x squared is equal to, just use this formula, a squared minus 2ab plus b squared. Okay, this square you will get y power 4 minus 2 times this, 18 y squared plus 9 squared, which is 81. So now I know that x squared is equal to this. Volume generated using this formula, pi x squared dy, pi x squared, which is this one, dy, and the lower limit, if this is dy, the two number here will come from the y-axis. So it's 0 until 2, 0, 2. Okay, now I just pull out the pi, and I will be start doing the integration for this part. Y power 5 over 5 minus 18 y power 3 over 3 plus 81y. Okay, the upper limit is 2, lower limit is 0. So copy everything, just change the y to the upper limit. Okay, y is equal to 2 to the power 5 over 5 minus, this is 18 divided by 3 is equal to 6, and y we change to 2 plus 81y. Okay, so minus, here you will get 0. Why? Because 0 to the power of 5, all this becomes 0 because you have y. Okay, so you just press your calculator for this part, then this will be the answer for this part C. 2 to the power of 5 over 5 minus 6 times 2 to the power of 3 and plus 81 times 2. Okay, which is equal to 120.4 pi. Don't forget the pi. Okay, cubic unit. This is the answer for this part.